Good morning students, welcome to the online class. Today's session is what is a scalar quantity, what is a vector quantity, and I am going to explain you some words: distance, displacement, velocity, speed, average velocity. Children, in the last class I told you about what is a motion and how this motion is relative to the observer. I explained you. Now in this class, first of all we will learn what is a scalar quantity. What is a scalar quantity? See children, a physical quantity which has only magnitude but no direction is called as a scalar quantity. A physical quantity which has only magnitude but no direction is called as a scalar quantity. See children, which has only magnitude means, that means it has some measure. It has some measure, that is but no direction. Suppose if we want to ask you what is the length of the classroom, then you can measure with your instruments like scale or tape, whatever you want you can take. So for that one we don't need any direction. No direction is required for measuring certain things. That is known as a scalar quantity. See children, the examples for this scalar quantity are length. For measuring length we don't need any direction. And in order to measure mass of a particular thing, that means also if you want to know your weight children, then you want to weigh or the mass of vegetables, then you don't require any direction. And if I ask you about what is the time now, you will tell it is 9 o'clock, 10 o'clock. That means here also there is no direction required. So length, mass, time, these are all examples for scalars. So these are, I told you in the previous lesson, length, mass, time are called as fundamental quantities. So these fundamental quantities are also examples for this scalar quantity. There are some more examples for this scalar quantity in this lesson. In the next class we will see. Next, what is a vector quantity? So a physical quantity which has both magnitude and direction is called as a vector quantity. A physical quantity which has both magnitude and direction, definitely here some magnitude is there and some definitely direction is definitely we want for this vector quantity. So the examples for this vector quantity are, in this lesson I will tell you velocity, displacement, okay children, velocity, displacement. These are all examples for this vector quantities, and how this direction will be utilized in calculating these vector quantities. Now I will explain you. Simply, what is a scalar quantity children? A physical quantity which has only magnitude but no direction is called as a scalar quantity. Examples: length, mass, time. What is a vector quantity children? A physical quantity which has both magnitude and direction are called as vectors. So for this one, in this lesson I am going to explain what are these examples for these vectors, that means velocity, displacement, etc. So children, after this we will go to another important topics in this lesson, that is distance and displacement. So for this one, distance. Now only I tell you what is the length of the classroom, then we won't require any direction. So in order to tell what is the distance covered by you from your home to the school, if I ask you, then what is its answer? See children, how much distance you have covered? Some 2 kilometers, 1 kilometers, half kilometer, like that you will tell. Okay children, and suppose if I ask you what is the displacement, so if you want to know the displacement, then definitely we want a direction, specific direction is there. So now here see here one object is there A, and here another object is B is there, children. Now here a person is moving from here to here, so he chooses the path from here A to B. So this curve, suppose if I keep any letter here, so then A, S, B is the length of the path covered by this object. Length of the path covered by this object A in order to reach B is ASB. That means he has travelled from A to S, S to B. So what is the definition of distance here? The length of the path travelled. The length of the travelled by an observer or object is called as a distance. The length of the path travelled by an object. Length of the path travelled by an object is called distance. So here there is no specific direction. You can choose any path from your home to school. So you can choose your own way. There is no restriction. Here you have to go straight, come here like this. There are no specifications of directions. So that is known as a distance, children. For distance we don't want any direction. Just how much distance you have travelled, how much length of the path you covered, how much the length of the path travelled by an object is called as a distance. Okay, children, here for distance I am tearing ASB. This is the shape. This is the path covered by the object A from A to B. So he chooses this path. Okay, children, this is the length of the path. And this distance is a scalar quantity or vector quantity, children? Distance is a scalar quantity. Distance is a scalar quantity. Why? Because here no direction. So that means distance is a scalar quantity. Now, what is the CGS unit of this distance? In previous lesson I told you C means centimeter, G means gram, S for seconds. So in this one length is measured with centimeters and the CGS unit of distance is centimeters and the MKS unit of distance is M for meters. So length is measured in MKS system meters. So the unit of distance in CGS system is centimeters and the unit of distance in MKS system is meters. And I told you it is a scalar quantity because there is no direction. Okay, children, do you understand properly what is distance? Now I am going to displacement. So displacement is the shortest distance. Shortest, it is a very important word, children. Shortest distance travelled by an object in a specified direction. The shortest distance covered by an object in a specific direction is called as a displacement. So in a specific direction, in the definition itself direction is there. So by seeing this we can say that this displacement is a vector quantity. Children, displacement is a vector quantity. Why? Because the definition itself includes direction. So it is the shortest distance travelled by an object. Shortest distance. Suppose from your home to school there are so many ways. Okay, children. Suppose if you chooses the shortest distance way, then that is your displacement, children. So distance and displacement. There are so many paths from your home to school. So if you choose any path on your wish, then it is distance, children. If I give you particular direction, okay children, you have to come, go straight like this, take the turn, come here, like that. If I tell you any direction and for the way for your coming to school, then that is known as displacement. So this displacement is a vector quantity. Displacement is a vector quantity because I am giving you the direction. Okay, children. So in order to calculate the displacement, definitely direction is there. And if I want to tell you what is the CGS unit of this displacement, distance and displacement are equal only, but only magnitude is same, but only direction is changing. So the units are also same, children. The CGS unit of this displacement is centimeters because C for centimeters and MKS unit of this displacement is meters. M for meters. Okay children. So the definition of this displacement is the shortest distance travelled by an object in a specified direction is called as a displacement children. So in this one, from this example, now I am going to explain what is displacement. So I told you previously ASB is the length of the path travelled by this person in order to reach B. So this is the distance. Suppose there are so many ways for reaching B. All these ways are there. So he can choose any way. But what is the shortest way in order to reach to B from A children? So if you join from A to B, so this is the shortest distance for remaining all. Children, AB is the shortest distance from A to B. There are so many ways from A to B, but only this AB is the shortest distance. So this shortest distance travelled by an object is known as displacement. So children, what is a scalar, what is vector, what is the distance, what is displacement? Now I will tell you how to draw the displacement vectors. So displacement means direction. So here they are given some points. So it is going from here. So if you want to draw the displacement vector, you have to join. Here the arrow is like this. So you have to keep arrow like this. So for drawing displacement vectors, you have to join the points. So here A's point is here, B's point here. So displacement, shortest distance, that means you have to join from A to B. So by drawing like this, we will get the displacement vectors. Now I am going to tell you what is average speed and average velocity. Suppose you took Godavari Express. It is coming from Vizag and it is reaching Hyderabad. Children, Vizag to Hyderabad. Godavari Express is going to Hyderabad from Vizag or Visakhapatnam. So the total journey of this express in order to reach Hyderabad is 720 kilometers. So suppose if it starts at 5 p.m. in Vizag and it reaches Hyderabad 5 a.m. in the next day. Okay, total what is the journey of this Godavari Express? Total journey 12 hours, because 5 p.m. in the evening at Vizag and it is reaching to 5 a.m. in the next day to Hyderabad. So what is the total time taken by this one? 12 hours, because 5 p.m. to 5 a.m. total 12 hours. And what I told you, what is the distance between the Vizag to Hyderabad? 720 kilometers. So in order to get the average speed, we can't say for every 1 hour. What is the distance covered by that one in each hour? So in order to get how much distance it has travelled per each hour, then we have to calculate the formula total distance by total time. What is the total distance, children? 720 kilometers by 12 hours total time. So if you cancel 12 6 are 72 and here 0 is there. So 60 kilometers by hour. So this is the average speed of this Godavari Express per 1 hour. So can you say that for every 1 hour the train is maintaining same speed, children? For every hour does it travels with 60 kilometers per hour speed? No, we can't say. It is not exactly same. But so for that one we have to take the average values. So we have to take the average speed. So in order to get the average speed, because every 1 hour it is not maintaining the equal speed. So that's why we have to take the average. So average speed is equal to total distance by total time. Average speed is equal to total distance by average speed is equal to total distance by total time, children. So here speed is equal to distance by time. So here I am taking average, so that means total distance covered and total time taken. Okay children. So average speed is equal to total distance by total time. So how can you define this average speed, children? The average speed is defined as the distance covered by an object in unit time. See children, distance covered by an object in unit time. Distance by time. So how can you define this average speed? Distance covered by an object. Total distance covered by an object in unit time is known as average speed. See children, here distance. Distance is a scalar quantity and distance by time. So speed is equal to distance by time. Average speed, if I ask you average speed, then you have to tell total speed, total distance by total time. Average speed is equal to total distance by total time. So if I ask you what is the definition of speed, so speed is equal to distance by time. Speed is equal to distance by time. So children, here for every physical quantity we have to tell it is a scalar or vector quantity. So a simple thing, distance is scalar and displacement is vector. So how can you say that this speed is equal to distance by time? What is how you can define the speed? It is the distance travelled by an object in unit time. Distance travelled by an object in unit time is known as speed. Now we have to say the speed is scalar or vector. So for that one, first take the distance. So distance is a which quantity children? Distance is a scalar quantity. So here distance is scalar. And what is the time children? Time is also a scalar quantity. So for defining speed is a scalar quantity or vector quantity, we have to express the terms distance and time whether they are scalar or vector. So I wrote distance is a scalar, and time is a scalar. So here both are scalar quantities. So finally speed is also a scalar quantity children. Speed is a scalar quantity. Why? Because distance is scalar and time is also scalar. What is the formula for speed? Speed is equal to distance by time. Say children again, speed is equal to distance by time. Distance is scalar, time is scalar, so speed is a scalar quantity. So average speed is also a scalar quantity. Now you want to tell the units for this speed. So average speed. Speed means distance. Distance is measured in centimeters. Distance is measured in centimeters in CGS and time is seconds. So centimeters by seconds in CGS and in MKS system meters by seconds children. Next coming to the average velocity. So for writing average speed we have to write distance. But in order to write average velocity, you have to specify displacement, because velocity, for defining velocity, we need direction. Suppose it is coming from west or north. Okay children, then due west and south, due north and east, like that if you tell the directions, then first of all from Vizag to it should come to Vijayawada, then only it should go to Hyderabad, because Vijayawada is in the middle of Vizag and Hyderabad. So that train should stop at Vijayawada and then go to Hyderabad. So from it is coming from the direction, this direction. So if you are telling in the direction wise, then we have to specify it is a vector quantity. So you have to specify displacement. Why? Because I am mentioning, if I am mentioning directions, then total displacement by time. Suppose if displacements are there, then it is known as average velocity. Okay children, if there is no direction, then it is the speed, average speed. If there is any direction, then you have to specify it is a velocity. So how this average velocity comes? Total displacement by total time. So displacement is a vector quantity and time is a scalar quantity. So in the two physical quantities, if one is vector quantity, then the entire quantity, the given quantity is a vector. See children, average velocity is equal to total displacement by total time. Total displacement by total time. Here displacement is a vector quantity. displacement is a vector quantity. So this is vector quantity and time is scalar quantity. So in the given two, if one is vector quantity, then finally the given quantity will be said to be a vector quantity. Okay children. So here displacement or distance, the CGS unit is centimeters and MKS unit is meters. So centimeters by seconds, it is the CGS unit, and for the MKS unit the displacement is meters and time is seconds. Therefore its MKS unit is meters by seconds. So do you understand children what is a scalar quantity? If a physical quantity has only magnitude but no direction is called as a scalar quantity. So length, mass, time, along with this what examples we can say children? Distance is a scalar quantity. So you can add this distance in this scalar and average speed also in this scalar examples children. Next vector. A physical quantity which has both magnitude and direction is called as a vector quantity. So here I told you velocity, displacement. So displacement is a vector. So average displacement, average velocity. Okay children, these are all examples for this vector quantity. So distance, the length of the path covered by an object is known as distance. Displacement, the shortest distance travelled by an object in a specified direction is known as, children, it is a displacement, it is a vector quantity. What is the average speed? Total distance by total time. So distance is a scalar, time is a scalar, so average speed is a scalar. Average velocity, total displacement by total time. Okay children, here in this one displacement is a vector, time is a scalar. So children, do you understand properly? Okay, thank you.